ماشي. This is Applied Math Mechanics Week 4, 1.5 to 1.10. As usual, we're going to start with the notes, which I still haven't opened. Okay, this week كله about graphs, URM, UARM. This chapter كمان next week will be the formulas of URM, UARM, but فيها شوي understanding. You actually have to understand this. Anyway, it starts أول شي بالposition time graph, XT graph. There's nothing really for me to explain here. It's just how to draw a position time graph. If the position remains constant, that means obviously the object isn't moving. If the position is changing at a constant rate, right? If the position is changing, it's increasing in a straight line, then you know it's a constant velocity. It's moving with a constant velocity. Nothing else for me any to say here. It's an XT graph. Over here, VT, okay, you have a VT graph. If velocity is changing at a constant rate, actually we know that acceleration here is positive since they were increasing, okay. And if it's changing at a constant rate, we know this motion is called UARM, right? And if it's not moving, if velocity isn't changing, if V is constant, does that mean our object is moving? Of course, yes. V is constant. We didn't say V is 0, V is constant. See, V could be like 2. It could be constant at 2. And this is what we call URM, because you're not accelerating. Acceleration equal to 0 in this case. Okay, and if you're decreasing at a constant rate, it's not UARM, it's uniform UVRM. Okay, these are just notes. Because there's going to be a lot of refer to the graph questions and label the graph. You'll see in the quiz, you'll see any. Okay, graphically, the average velocity is equal to the slope of the secant line connecting the 2 points. They could also say tangent theta is equal to the slope. These are all just random notes. The most important part is, what do I mean? Let's say you have a curve. This is V, or yeah, this is xt. It's a curve. It's not a straight line. When you want to find the average velocity between this P1 and between P2, okay, how would you do it? Obviously, we know you do time. Let's say this is TF and this is TI. You do you do, like, this is V1, this is V2. You do V2 minus V1 over TF minus TI. We all know this, right? But it's not going to tell you that in the exam. They're going to tell you the average velocity here is equal to the slope of the, and you have to say secant, okay? Average velocity is equal to the slope of the secant. For those of you who don't know what the secant is, in a circle, okay, we took this in math, in geometry. In a circle, a line that intersects the circle at one point is called a tangent. A line that intersects the circle at 2 points is a secant. In other words, a secant is a line that intersects the curve at 2 points. So it's the slope of the secant because it's here. This is the secant, right? This red line. It intersects it here, intersects here. And isn't the slope of that just y2 minus y1 over x2 minus x1, right? y2 would be v2, right? And then y1 would be v1, x2 would be tf, x1 would be ti. It's the same thing as the slope. Okay. Graphically, the instantaneous velocity is equal to the secant joining the tangent, okay? El average, see, and I really don't like this concept, but the average velocity is equal to the slope of the secant, right? Because we want 2 points for average. But for instantaneous velocity, it's equal to the slope of the tangent. So, like, let's say, and I want at here, let's call this P1. I want the instantaneous velocity here. I draw a tangent, like I drew here, that intersects the curve at that point, and you just find the slope of the tangent. Okay, this is all hebel, okay, and I don't like this concept at all. Okay, note, slope is equal to rise over run, which is equal to x2 minus x1 over t2 minus t1. This is just to show that the slope of any line on an xt graph is actually the velocity, right? Okay, xt, again, here, if it's increasing with a straight line, yani it's increasing with a constant velocity. So it's URM. This is for xt, huh? This is for xt. If the position doesn't change, that means our object isn't moving, and if it's not moving, v equals 0. Okay, كمان هلا if v is decreasing at a constant rate, sorry, if x, sorry, not v. If x is decreasing at a constant rate, yani it's moving at a constant velocity, right? The change of x with respect to time, this is velocity, right? So here it's gonna be velocity constant and also URM. You don't say UVRM because UVRM is for acceleration. احنا هيدي URM, it doesn't matter. Okay. This is just exercise. Look, exercises. Holy, I think grids. We're gonna solve these at the end of the video. Okay. VT graph. Average acceleration we know is equal to delta V over delta T, which is Vf minus Vi over Tf minus Ti. The SI unit of this acceleration is meter per second square, and you can also find average acceleration by just finding the slope of the secant. If it's average, you find the secant. If it's instantaneous, you find the tangent. Okay. Obviously, acceleration is a vector. Instantaneous acceleration. Okay. What is instantaneous acceleration? I put this in my notes last week, and many people did not. They didn't understand it. Okay. Instantaneous acceleration, A instantaneous, is equal to the limit of acceleration as delta T approaches 0. As delta, this means, yani, if you have the curve, okay, whatever, like this. This is V, this is T, okay? You have 2 points, or let's say you want P1, okay? The limit, delta T equals 0, because you know this is T1, and this is, I don't know, let's say, T2, okay? Delta T equals 0 means the difference between T2 and T1 has to be 0. If the difference between 2 times is 0, doesn't that mean, you know, they're the same time, right? So basically what they're trying to say, when you say delta T approaches 0, it's basically trying to say that it's at one point, it's at one specific point. You're going to learn a lot about limits in math and this year and in calculus, so you'll understand it more. But limit in general just means delta T approaching 0. That means I can't breathe. Wait. Okay, and then they said dv over dt. Okay, dv over dt means the derivative of velocity. This is all, again, this is useless. Like, it's useful, but like they never ask these types of questions. You know, what is it equal to? Oh, derivative of velocity. No, they don't ask these questions. Anyway, this is just applications of formula. Like, guys, it's so easy. Wallah, you don't understand. You just plug in. It's the same questions, by the way. Okay, acceleration is the slope of the secant connecting 2 points in the VT graph. We're just repeating ourselves. You see, this is a VT graph. You have a point here, point here. How do you find the average acceleration? You just do V final minus V initial over T final minus T initial, which is the same thing as the slope of the secant connecting them. And when we say tan theta, by the way, what we mean, in case it comes, this is a triangle, right? Over here. Okay, it's a right triangle. Tangent of this angle, tan theta, is equal to opposite over adjacent, right? What's the opposite side? It's this here, which is VF at the top, right? And this is V node or V initial, whatever. Isn't it just equal to, how much is this? Isn't this VF minus V initial, right? Over adjacent, isn't it this? T final minus T initial. Isn't this equal to average acceleration? Isn't this equal to the slope? Rise over run. In case it comes, any. You know, sometimes they can say, oh shit, you know what? Like, I don't know, I'm imagining a question they could bring. They could say the angle theta that the secant makes is 25 degrees. How much is the average acceleration? You just do tan 25. Okay. Okay. A instantaneous is limit A delta T approaches. I'm rewriting the same notes over and over again, yani. Okay, which is limit delta V over delta T, which is equal to dV over dt, derivative, blah, blah, blah. Ya Allah. Graphically, instantaneous acceleration is the slope of the tangent. Yani, if it's instantaneous, just literally, I'm repeating myself, guys. If it's average, it's slope of the secant. If it's instantaneous, it's slope of the tangent. Like, wallah, I don't even know what to say anymore. I'm repeating the same things. Okay, this is blah, blah, blah. Okay. My God. UARM stands for Uniform Accelerated Rectilinear Motion. I don't even remember taking this down. Okay, if A is constant, but if A is constant, but it's less than 0, it's UVRM. If A is positive, then the body is speeding up. right? If A is positive, then the body is speeding up, and if it's less than 0, then the body is slowing down. If A is equal to 0, then the body is at rest or it's moving with the constant velocity, right? If it's at A equals 0, yani velocity is not changing. So it's either velocity is constant or velocity is equal to 0, meaning at rest, right? Study for figure 1.2. Okay, yeah, this is, we need this. Page 33. Anna, hold up. Page 33. Is page 33. Figure 1.25. Not this. Yes, it was this one. This has to do with, yeah. Yes. Okay. So, this one here, they get it in a lot of exams. Oh, I have to zoom out. I'm gonna take this. Oh, I'm gonna take it. Where? I'll just screenshot to take. Okay. You have a VT graph, right? VT. It starts at 0 and it's moving up. Moving up. صح؟ Moving up يعني شو؟ Positive direction. Velocity is increasing. Right? It's moving in the positive direction. Velocity is increasing at a constant rate. If it's increasing at a constant rate, what does it mean? It's uniformly accelerating from rest. Right? Okay. هلا it plateaus. Velocity stops increasing, stops decreasing. It just stops. It just stays constant for 12. So if it stays constant, يعني it's moving at a constant speed. هلا here you can say, is it, how do you know if you're in the positive direction or in the negative direction? Okay, you know if it's above the x-axis or whatever t-axis, then here it's positive, and if you're down, it's negative. So here we're still moving in the positive direction, but now what are we doing? We're decelerating, right? We're decelerating because velocity is decreasing. You're not supposed to write all of these, but you know it's gonna come multiple choice. Okay, then here you reach v equals 0, so you come to an instantaneous stop, right? Why? Because now we're about to change our direction and move in the negative direction, right? We were in the positive, hello, we're going into the negative. So to change from positive to negative, we have to pass through 0, v equals 0. So we have to stop for like a second. Okay. Allah, we're moving in the negative direction. And we're moving in the negative direction, but we're uniformly accelerating. The Walid, like, aren't you, in the negative? So isn't your velocity technically becoming smaller? No. You're slowing, so you're speeding up, but just in the negative direction. Okay? Hala, here again we stop moving, so we're moving at a constant speed. No, there's no more acceleration, so it's moving at a constant speed. Then here it's moving again in the negative direction, but it's uniformly decelerating. How do you know if it's accelerating or decelerating? Here's a good trick. If it's moving away from we can call this 0. If it's moving away from 0, that means it's accelerating. But if it's moving towards 0, like over here, it's decelerating. Here also, it's going up towards the 0, so it's decelerating. Okay, I hope that makes sense. Because this question comes. Okay. هلا here, interpret the xt graph for accelerated motion. Okay. Here, we have another VT graph. We have a curve. If it's curved, does that mean it's a constant acceleration? No, it doesn't mean. If it's curved, it's a varying acceleration. Although it's increasing, okay. Hello, I explain it here, the types of curves. Okay, although it may be increasing. Hold up, I forgot what I was saying. Yeah. You're speeding up, right? Although it may seem like you're speeding up, the acceleration here is actually decreasing. Okay, so acceleration, is it positive? Obviously yes, right? But it could be 5 reaching 4 reaching 3 reaching 2 reaching 1. But why? It stopped over here, like it started to become constant. So akid, if it's starting to become constant, this acceleration is decreasing. Okay, here akid in 2 velocity is constant, so acceleration is equal to 0. 3, it slows down. but it slows down at an increasing rate in the positive direction. Again, it's still in the positive direction. And then 4, it slows down in the positive direction till it stops. Okay, I'm gonna explain this. Some people here, they don't understand why is the acceleration decreases when you're increasing. There are 4 types of curves. Okay, this is very important, and it will help you answer every question. Okay, 4 types of curves. We're gonna look at these 2 first, and then look at these 2, the other 2. Okay, to start off, this curve here, we're going up. Let's say this is VT, right? We're going up, so we're accelerating. Type at an increasing rate or a decreasing rate. Let me see. What's the difference between this curve here and this curve here? This is what we call convex. Okay. Or is it? Wait, no. Is it convex or hold up. Yeah. This is convex, and this is what we call concave. The name doesn't matter, but just so you can understand a bit. This is concave. Okay. Let's see. What's the difference here? It curves until this point, right? Okay, let's say you extend this point. Start extending it. What starts to happen? It begins to become constant. So is it still accelerating at this point? No. How about here? If you continue the line, besides going up, it's going up, so you continue it up. It's still going up here. What's the difference between this one and this one? Here it's continued to go up. Here it began to plateau. Plateau yani it began to become straight. Okay. So which one do you think is accelerating at an increasing rate and which one's decreasing? Actually, the one that continues to increase is accelerating at an increasing rate. But the one that begins to become straight, actually that one's increase is accelerating at a decreasing rate because decreased its acceleration. So that's why over here, if you look at the curve, okay, this is a convex curve. This type of curve, it begins, see we extended it, what happened? It began to plateau, it began to become constant. So although it's accelerating at a decreasing rate, okay? And that is positive direction, blah, blah, blah. How about this here? Let's now look at the other 2 curves that is left. Okay. This one here. This is, again, convex, okay? It's decreasing, right? It ends at this point, okay? Continue the line. What happens? Is it still going down? Yes. So now we know for a fact it's slowing down, or we could say it's decelerating. But is it decelerating at an increasing rate or a decreasing rate? We continued off the line. What happened? Is it still going down? Yes. So that means it's still decelerating. So it's decelerating at an increasing rate. How about this one here? It's slowing down. We know it's decelerating. But continue off the curve. What happens? It begins to become constant, right? See? It begins to become constant. So what does that mean? Is it still slowing down? No, it began to become constant. So that means decelerating at a decreasing rate. So it's not really decelerating anymore at the end. Okay. XT graph for accelerated motion. Okay, this is derivatives. This is I don't think I have to explain. Let's say you have y is f of x. What's the derivative of y? Y prime is equal to f prime of x, which is equal to the derivative of the y, dy over dx. Okay, derivative of y prime is y prime prime. Okay, and it's equal to f prime prime x, which is equal to d over dx dy over dx, which is d squared y over dx squared. Okay, this is all just general stuff, whatever. Okay. This is just to show that if the derivative of a function is positive, that means obviously it's increasing. Okay, and that means obviously its second derivative is positive again. Okay, and how would you draw it? It would be concave up. Concave up is this one. Concave is like this. Right, so since it's positive, it's going to continue to increase. If y prime is equal to 0 and the slope is equal to 0, then actually the second derivative is equal to 0, and that means it's a stationary point. This is calculus. Like, they won't ask these questions. We're gonna learn it in math soon enough. Okay, and we already know this, but we'll redo derivatives. I think we're redoing it now for most people in class. If y prime is obviously negative, then it's gonna be decreasing and it's gonna be concave down. So it's gonna look like this. Or is that convex? concave. This is just concave down. Hello. Yeah, no, this is correct. By the way, one way to know and how I remember which one's concave, which one's convex. For those of you who don't know meniscus of water, okay, when you look at water, okay, it's kind of like, you see, it's like this, like it's like this. You see how it's like curved. So this would be a downward concave. This would be an upward concave. The meniscus of water is what characterizes convex and concave. Okay, forget about this convex because this is wrong. Mercury, this is mercury, but water is concave. You see? So نحن أنا هيك. That's how I remember it. You can do your whatever way you want. Okay, this is a concave curve. Yeah, I even drew it here. Okay, we have 5 stages, and this is an XT graph. 1, it's curved, right? It's curved. If it's curved, going downwards. Okay, if it's downwards, or it's negative direction, right? Is it moving away from the origin? Yes. So that means it's accelerating. So it's accelerating in the negative direction. If it wasn't curved, if it was just a straight line, if it was just a straight line, then it would be velocity, right? But it's curved. In terms of math, a curve, let's say it has x squared. Let's say the equation of this curve is x squared. Derive it. What do you get? You get 2x. So the velocity is 2x. Can you derive one more time? You can derive 2x, right? You get 2. So that means acceleration is 2. If you guys remember from IGCSE math, we have x, v, t as the x, v, and a. If you derive x, you get v. If you derive v, you get a. Okay? That's also in terms of math, a way you can explain this. If an xt graph is curved, yani it's accelerating. If it's a straight line, it's velocity. These are all just things you have to remember. Okay? 2, I think it's... Also, one reason why this is accelerating is because if you extend this curve, it's continuing to go down, right? So it's accelerating. That's why here in phase 2, instead of it's also curved. This is also a curve. Okay? Instead of accelerating, this is decelerating. Because look, extend it. Wait, no, that doesn't make sense. That doesn't make sense. I think Anna, I should show you from the book because my drawing might be a bit bad. 39. 39 is over here. Yeah, okay. Over here. Yeah, so my drawing was a bit messed up. So they labeled this 3, 4, 5. 1 is this over here. Okay? Continue this curve, it continues to decrease. So that means if it's continuing to decrease, and it's continuing to move away from the origin, that means it's continuing to accelerate in the negative direction. Remember, this is how we interpret curves, guys. Curves you have to see, you have to continue off the curve, see if it's continuing to decrease or if it starts to become straight. How about here in phase 2? This is the curve in phase 2. Let's see, continue it. What happens to it? Begins to become constant. So is it accelerating anymore? No. It's beginning to become constant, and خلاص it's decelerating. But still, we're in what direction? In negative direction. هلا 3. 3 is when it's constant. X is constant. So that means V equals 0, صح? If I'm not wrong. Yeah, V equals 0. Okay, then... Oh, shit. Let me zoom in. Okay. Then 4, it's a straight line. If it's a straight line, is it accelerating anymore? No. But there is velocity, right? It's velocity. So velocity is greater than 0. It's speeding up. Or is it slowing down? It's slowing down, صح? It should be slowing down in the negative direction. Yeah, oh, they just want you to... Okay. It's just slowing... It's just say you just say V is constant. Why is V constant? Because it's a straight line in an xt graph. Okay, so V is constant here. Just say V constant. Let's forget about this. And then 5, again, it's a curve. And this is a curve. If you extend it, it continues to go up. So that means it's accelerating And this time we're in the positive sense. Okay, let's take a look at the answer. So for v is constant, and it was greater than 0 because it's going up, okay? And then 5, they just said UARM. Okay, ماشي. I don't mind. Okay, an AT graph. Okay, AT graphs are so easy, wallah. Okay, AT graphs, they usually look like this. It's just lines. Okay, there's no connection. Okay, because you suddenly go from 2 to 0. Okay, like that's the thing with acceleration. It's very sudden. Okay, like this is another example of an AT graph. Again, just very vague. It's like there's nothing there's nothing to comment on. URM is uniform rectilinear motion and is the motion on a straight line with constant speed. We know uniform rectilinear motion is when you have constant velocity, right? Here, xt, the graph is a straight line. That means it's a constant velocity. What do we say if it's a straight line? Straight line, not curved. Yani, is there acceleration? No, there's no acceleration. But x is changing, so that means x, the change of x with respect to time, we know that's velocity. It's a constant velocity. What's the equation of motion for URM? X equals vt plus x naught. We know that v is equal to delta x over t, which is equal to xf minus xi divided by t. Is equal to v. Multiply by t, you get xf minus xi equals vt. So you get final x is equal to vt plus x initial. Okay, this is just application of the formula. Okay, know that displacement is the area under the VT graph for all types of motion, right? For all types of motion under the VT graph, the displacement would just be the area under the VT graph. Okay, usually it could be a trapezoid, it might be a triangle. In the book في فلسفة كتير عن هالموضوع over here. And if it wants to load, yeah, it has to do with integrals وما بعرف شو. This is all هبل. Okay, forget about integrals. You're not responsible to know about integrals. So forget. See, حتى here area under the graph. You're gonna learn later in calculus. If you want to calculate the area under a curve, you're supposed to use integrals because it's a curve, and we in geometry we don't know how to calculate these like small parts that are left over. Okay, and if you zoom in even more, you're gonna find more small parts. That's the thing with curves. That's why they invented something called the integral, and the integral is basically slicing it up into different shapes and adding up everything. Okay, that's later. That's for math. It's calculus 1. Anyway, we're done this. Halla, we'll do the quiz. Okay, question 1. What is the acceleration of the object between 0 seconds 2 seconds? It's a VT graph, so we can directly find the average acceleration is the slope of the secant. So you take 2 points. So 0 seconds is 0, 0. 2 seconds is over here at 4. So you do 4 minus 0 over 2 minus 0, which is 2. Okay, what is the net displacement of the object? How do you find displacement in a VT graph? In a VT graph, how do you find displacement? You have to find the area, and they're saying net, so يعني total. Okay, so شو بنلاقي? We find the total displacement. Our shape هي it's a trapezoid. Okay, let's see. Base 1 is 10. Base 2 is from 2 to 6, so that's 4. So base 1, because you know an area of a trapezoid is b1 plus b2 over 2 times height. Okay, 10 plus 4 over 2 times the height, which is 4. You get 14 divided by 7 times 4, 28. 28. Question 2. Okay, the magnitude of the drone's velocity at t equals 2 seconds. Okay, so this is it says st, but s is another letter for x. Okay, and if you don't know, just look at the unit. What's in meters? What do we write meters? Meters is x, right? So this is another word for x. So this is an xt graph. The velocity at t equals 2 seconds. The instantaneous velocity. Okay, some people will do 15 divided by 2. That's wrong. You can't do that. Okay, here's what you do. Isn't the instantaneous velocity the slope of the tangent? Yes. So it's the slope of the straight line that touches this point. And isn't it already a straight line? Yes. So instead of saying the slope of the tangent, when your graph is just a straight line, it's the same thing as just finding the slope. How do you find the slope? We'll take these 2 points. We have 2 seconds, 15 meters, and we have 4 seconds, 10 meters. How do we find the slope? x2 minus x1, 10 minus 15, over 4 minus 2. You get 5 over negative 2, no, negative 5 over 2, which is minus 2.5 meter per second. But they said magnitude, so it's positive. Okay. Question 3. A car initially moving at 30 decelerates to 5 in 3.8 seconds. What's the acceleration? A equals v final minus v initial over t. So it's going to be 5 minus 30 over 3.8. So minus 25 divided by 3.8, and you get minus 6.6. Very easy. Again, question 4. What is the magnitude at t equals 1 second of its acceleration? Now it's a vt graph. It's the same thing as question 2. Okay, we want acceleration, instantaneous acceleration. Isn't it the slope of the tangent? Yes, and this is already a straight line. So can you find the slope of the tangent if it's already a straight line? The tangent to a straight line is the straight line of it itself. So we could just say it's the slope of the graph. Okay, so let's take 2 points. They want 1 second, 1 meter per second. Okay, and then we could say, I don't know, 1.5, 0, 1.5 seconds, 0 meter per second. Okay, how do we find the slope? 0 minus 1 over 1.5, 1.5 minus 1, which is minus 1 over 0.5, which is minus 2, but they said magnitude, so keep your answer positive. So it becomes positive 2, huh? Question 5. How many questions? 16? Okay, question 5. The total displacement of the cyclist. If it's a VT graph, how do you find displacement? You find the area. This is a triangle. You know that the area of a triangle is base times height over 2. The base is 80. The height is 6. This is the height, because it makes a right angle. Okay, so 6 over 2, and you get 240. Okay, 80 times 6 over 2 is 240. Okay, okay, the diagram below shows the variation of a car's velocity with respect to the time. They give us the tangent at 10 seconds. What is the instantaneous acceleration? Didn't we say instantaneous yani slope of the tangent? Slope of the tangent. That's why Aslan they drew for you the tangent. If it's on computer, they're going to draw it for you. Okay, so what's the slope of the tangent? We have to take 2 points. Okay, so let's take this point here at t equals 10 seconds. It's 10 seconds, 5 meter per second. Come in here. This point is good because we want a point that you can actually see its coordinates. Like these, you don't want to estimate. This is exactly on the corner, so you can take that. 40 seconds, 15 meter per second. How do you find the slope? 15 minus 5 is 10 over 40 minus 10 is 30, so you get 0.33. Okay, 0.33. These questions are all extremely easy. Okay, the graph below shows how 3 runners competed in a 100-meter race. You have Albert, Bob, and Charlie. Okay, which runner won the race? So okay, the one that won the race is the one that finished the 100 meters first, right? So which one reached 100 meters first? Why is it Albert? Okay, yeah. Which one reached 100 meters first? Albert, because Albert reached it over here at like almost 12 seconds, right? But Bob reached it at 14 and Charlie reached it at like 17 seconds. So okay, the one who won the race is Albert. Which runner stopped for a rest? Okay, the one that stopped for a rest is the one that stopped moving for some time. Okay, that one is Charlie. You guys, these, yani, wallah, I think if you get my brother from grade 6, you can solve these types of questions. Okay, here. This is a nice question. They gave us the equation of the displacement is 2t squared. Let's forget about this meter per second stuff. It's 2t squared minus 8t plus 3. They gave this is xt. Okay, what is the initial velocity of the particle? So remember the derivative change as the derivative chain. If you derive x, you get v. If you derive v, you get a. Now we want the velocity, the initial velocity. Okay, the initial velocity, that means we're looking for v, right? So if I'm looking for v, I need vt. How do I get vt if I have xt? I just derive xt, right? Remember this, velocity is equal to dx over dt, which means the derivative of x with respect to time. So let's derive dx, derive it, 2t squared becomes 4t, Remember, power times coefficient 4, then reduce the exponent by 1. 1 times minus 8 is minus 8. Reduce the exponent by 1, خلاص the t is gone. And this 3, it's 3 to the power of 0. 0 times 3, it's 0. So if you derive it, you get vt is 40 minus 8. هني قالوا initial velocity. Initial means time equals 0. Substitute 0, 4 times 0 minus 8, you get negative 8. Okay? The average velocity. What is average velocity equal to? Average velocity is equal to x final minus x initial divided by time, or let's just say divided by time. So Anna, do I need xt or vt for the average velocity? I need xt, right? Because average velocity is equal to final minus initial x, not final minus initial v. So let's see here. Final minus initial x, here they want in the first 10 seconds. We found that the initial displacement at t equals 0, or we didn't find it, we can find it. So how do we find it? In the first 10 seconds, يعني they want the initial is t equals 0. Okay, you're starting at 0 and you're finishing at 10 seconds. So we want 2 points. Let's see, 0 seconds. How much is it at 0 seconds? How much is my x? Substitute 0. 2 times 0 is 0. 0, you get 3, right? 2 times 0 squared minus 8 times 0 plus 3, you get 3 meters. Okay, how about 10 seconds? Let's substitute 2 times 100, because 10 squared is 100, minus 8 times 10 plus 3, which is 200 minus 80 plus 3, so you get 123. 10 seconds, 123 meters. Can you find average velocity? Yes. Final minus initial, it's 123 minus 3 is 120, divided by time, final minus time initial, 10, which is 12 meter per second. Okay, select the diagram that correctly shows the vt graph of the motion of the particle. So we have the average velocity, which is positive. So that means it's increasing, right? It's increasing. Since it's positive, it's increasing. But with the initial velocity, this means it's increasing. And since it started at negative, that means the first point should be at negative. Is it this one? أكيد no, because we're supposed to start at negative. Is it this one? أكيد also no, because we're supposed to start at negative. Is it this one? No, this one goes up, then goes back down. Did we say anything about going back down? No, right? But this one, it starts at negative and continues to go up in a positive trend. That's why it's that one, okay? Question 9. I like this question. صراحة. Okay, now question 9. The net displacement over the course of the 30 seconds is... Okay, please be careful. It's an xt graph, so you don't have to find the area here. It's يعني واضحة. You just find the displacement. You start at 0, you finish at 4. But wait, how do you know it's 4? Okay, it's 20 divided how many spaces do you have? 1, 2, 3, 4, 5. 20 divided by 5 is 4. That means each space is 4. Okay, so you finished at 4. What's displacement? It's final position minus initial position. So 4 minus 0 is 4 meters. The total distance traveled by the particle over the course of 30 seconds is how much meters? Okay, the total distance is very easy. Okay, we went up. Total distance, yani you find that the total path. And we went from 0 to 20, that's 20. Then we went from 20 to 0, that's another 20, right? Then we went from 0 to, this is minus 8. So to go from 0 to minus 8, that's 8 meters, right? Because over here it's at minus 8. It's minus 8 meters. Okay. Then we stayed constant and we went back up to 0. From minus 8 to 0, that's another 8 meters, right? And then we went up to 4. Let's add this all up. 16 plus 4, 20. 20 plus 20 plus 20, 60 meters. Okay. Part B, the average velocity of the particle from 0 seconds, 14 seconds is what? Average velocity is final minus initial over time, right? What's the final position at 14 seconds? Let's see, 14 seconds. Let's erase this. I don't like this. At 14 seconds, how do we know how much each space is? 10 divided by 1, 2, 3, 4, 5 spaces. 10 divided by 5 is 2. That means it's 2, 4, 6, 8, 10, 12, 14. At 14 seconds, it's at negative 8, right? Negative 8. So you have 0 seconds, 0 meters, and 14 seconds, negative 8 meters. Okay. What do we do now? We do final minus initial divided by time. Negative 8 minus 0 is negative 8 over 14 minus 0, which is 14. Well, I think you get here, divided by 2 up and down, you get 6 over 7. 6 divided by 7. No, 6 divided by 7. 4 divided by 7. You get, 0. Negative answer. No, negative 4 divided by 7. Because I divide up and down by 2. Yeah, you get minus 0.57. Okay. the average speed of the particle in 0 seconds, 14 seconds. Speed is distance divided by time, صح? So what's the distance traveled from 0 seconds, 14 seconds? Let's see. Here it's 20. Here it's another 20. Here it's 8, right? From here to here it's 8. So 20 plus 20 plus 8 is 48. Divided by the time, which is 14 seconds. Ooh, it should be 3.43. Let's see, 48 divided by 14. 24 over 7, which is 3.423. Two decimal places is 3.43. Okay. Question, is that it? Wait, hold on. Yeah, okay, that's it. Question 10. Okay, the moment of time when the particle is instantaneously at rest. When is it at rest? When is it at rest? It's when it stays constant, like it doesn't move. This is xt, right? Not when it's at 0, no. When it stops move, when it becomes constant. Here it goes up. Here, for like a small instant, it changes direction. To change direction, that means you have to stop for a second, right? So any stationary point, that's actually when it's instantaneously at rest. And this is at time equals 5. Okay? At t equals 11 seconds, the approximate instantaneous velocity is how much? 11 seconds is over here, right? So you draw the tangent to this. How do they get minus 6? Let me see. It's 12. Minus 12. Minus 12 divided by 2. Yeah. Okay. So it's basically, how do we find instantaneous velocity? We find the slope of the tangent, right? And this, the tangent to this graph over here, it would be like this, right? It intersects this graph only at this point here. How do we find the tangent of it? We need 2 points. Let's see what 2 points are easy to work with. We have, if you extend down here, you have this point, which is at 12 seconds. Is that 13 seconds? Yeah, that's at 13 seconds. This is at 11 seconds. At 13 seconds, it's at negative 12, right? Because we said this is 4, negative 4, this is negative 8. It goes by 4, because 20 divided by 5 spaces is 4. So we have a point 13 seconds, negative 12 meters. We have a point 11 seconds, 0 meters. What do? We do final minus initial, right? Our final is negative 12 minus 0 is negative 12 over time final minus time initial, 13 minus 12, 2, which is negative 6 meters per second. Okay, at t equals 11 seconds, the approximate instantaneous speed is 6. Listen, if you have instantaneous velocity at a certain instant and they ask you to find instantaneous speed, instantaneous at the same time is equal to the absolute value of v instantaneous, okay? Because speed is never negative, it's always positive. That's it. It was the absolute value of negative 6 is 6, because what's the positive value of negative 6? It's 6. Question 11. In the first leg of motion, a bicycle accelerates from rest in the positive direction at 1.5 meter per second squared for 6 seconds. In the second leg of motion, the bicycle decelerates to a full stop in 5 seconds. The magnitude of deceleration in the second leg is how much? Okay, to find acceleration, okay, it's Vf minus Vi over t, right? Now here you're going to need to use some UARM. I want to know, it decelerates to a full stop, and V final is equal to 0. But how much was the velocity before it stopped? Let's see. It accelerated at 1.5 meters per second squared for 6 seconds. So each second it gained 1.5, right? So how much would it have gained? 1.5 times 6, which is equal to 9. So it was at 9 meters per second. So V initial is 9 meters per second. In other words, if you have acceleration, you have the time, and you want to find velocity, we know velocity is equal to acceleration times time, because acceleration is equal to velocity divided by time. So velocity is equal to acceleration times time. So 1.5 times 6, which is equal to 9. Okay, 9 meters per second, that's the initial velocity. The final velocity is 0. So 0 minus 9 over the time, which is 5, which is minus 9 over 5, which is minus 1.8. Okay, and they want the magnitude, so it's just 1.8. Drag and drop the correct answers. If the bicycle speeds up in a positive direction, أكيد A is positive. If the bicycle is slowing down in a positive direction, أكيد it's negative. If the bicycle speeds up, if it's speeding up in a negative direction, أكيد acceleration will be negative. Look, if you're speeding up in the negative direction, that means you're going down. If you're going down, isn't that negative or positive? That's negative. It's negative. If it's slowing down in the negative direction, this is different. Slowing down in the negative direction, معناته your velocity was negative 12, it became negative 4. So let's say you were at negative 12 and you became now negative 4. Okay, you're approaching 0. If you're approaching 0, are you slowing down or speeding up? Akid, you're slowing down. Okay, is this graph going up? Yes. Does that mean it's positive or negative? It means it's positive. That's also how you solve all of these. If it's speeding up in a positive direction, معناته it's going like this. We know this is positive. If it's slowing down in the positive direction and it's above, but it's going down since it's slowing down, okay, this is negative. If in the third case it's speeding up in the negative direction, means it's speeding up. That if you're speeding up means you're going away from the origin, away from 0. If you're going away from 0, like you in the negative direction, that means it's going like this. This is negative since it's sloping downwards. Then it's slowing down in the negative direction. If you're slowing down, that means you're going towards 0, but from the negative side. So from negative direction, and from below, you're going up towards 0. Is it sloping upwards? Yeah, that means it's greater than 0. Okay, this is a nice way to solve this type of question. Question 12. Okay, you have car A, you have car B. Which is moving faster at the start? Akid car A. Which one ends up further? Akid car B. I mean, that just makes sense. Which car experiences a greater magnitude of acceleration? Akid A, because it's a steeper line. Yani, what is this stupid question? Question 13. Okay, car A, B, and C are all accelerating steadily and then continue their motion at a constant speed. The speed time below summarizes only A and B. What's the maximum speed of car A? Okay, 30. The distance traveled by car B. Okay, نحنا we have constant velocity, right? Oh, they said while accelerating. Okay, so for part here, you need a UARM formula, but the UARM formulas aren't required for this week. So I don't think they will bring it. But just in case, while accelerating, you have you have acceleration, right? And you have the time, but we want X. Okay, from the UARM formulas, the one that gets you X when you have acceleration and time is X equals half AT squared. Okay, so if X equals half AT squared, so half times the acceleration. How do you find accelerating? Acceleration is final velocity minus initial velocity divided by time. The final velocity is 20, okay, and the initial velocity is 0, so you don't write it. Divided by the time. Again, the initial time was 0, but it took 15 seconds to accelerate. So your velocity is, as your acceleration is 20 over 15. And the time is 15 seconds. It took 15 seconds of acceleration, so times 15 squared, and you get 150. Okay, but this, I don't think it will be required. Assume that car C has a greater acceleration than car A, but it reaches a lower constant speed than car B. Select the possible speed time graph that represents the motion of car C. Okay, so it has a greater acceleration than car A. Okay, if it's greater acceleration than car A, that means it was steeper. Okay, that means it took less time. It took less time to accelerate. Car A took 15 seconds. So just this one is going to take less than 15 seconds. All these graphs, it's not going to be this one because it took, let's see, 15 seconds. This one also took 15 seconds. We don't want that. We want it to take less than 15 seconds. We want it to be steeper. These ones both take less than 15, but let's look at the final velocity. They said that it has the final velocity, it's lower than B. Let's see, how much is B? B is 20, so it should be lower than 20. This one is 25, so okay, this is wrong. We want lower than 20, so 15 would work. Okay. Question 14. 14. This is an Excel. Oh, no, they won't get this. They will not get this. Okay, this is an AT graph. The acceleration of the elevator at t equals 2 seconds. I remember this question from grade 10. At t equals 2 seconds, we know that the acceleration is 4. The instantaneous velocity at t equals 4. Okay, at t equals 4. How much is the acceleration? Hold on. Let me interpret this for you before I solve part B, okay? You're accelerating at 4, then you stop accelerating. So that if you're stopping acceleration, that means your v remains constant. Let's see, at 4 seconds, again, this is a UARM formula. At 4 seconds, v equals, a equals velocity divided by time, so v equals acceleration times time. So v equals the acceleration, which was 4, times the time, which was 4 seconds, right? So, Walid, why don't you use acceleration equals 0? Ma, habibi, if acceleration equals 0, that means the velocity remains constant. So that means the velocity is the same as the velocity that was up here. Okay, so v equals 16. The displacement of the elevator at t equals 32, as the t equals 4 seconds is. Again, you need a UARM formula. That's why you can use half AT squared here, not for this one. You're going to use half AT squared because you have the acceleration, you have the time, and you want x. If you want x with acceleration and time given, you use x equals half AT squared, which is x equals half times acceleration, which is 4, at t equals 4 seconds, it's 4, right? Okay, times the time squared, which is 4 squared, you get 32. And I just want to make sure UARM formulas are not required. Until 1.10. 1.10 هي displacement under the VT graph. هن هول الformulas. See, half AT squared is 1.11. يعني I know I'm not tweaking. Okay, the acceleration of the elevator at t equals 10 seconds. Just go to t equals 10 seconds. How much is it? Minus 4. Instantaneous velocity after 12 seconds is 0. Okay, let's see. Why is it 0? Okay, here اتفقنا it was 16. Here it remains 16. And then here, okay. So it was 16, it remains 16 because acceleration is 0, so it remains constant. But هلا it went negative 4. So again, v equals the acceleration is negative 4 times how long was it? 4 seconds. So v equals negative 16. So لو كانت 16 هلا it went down by 16. So هلا how much does it become? 16 minus 16, which is 0. Again, guys, I doubt they will get this question. Okay, I doubt they will get it. Okay, so هلا when it reaches this here, it's gonna become 0. Okay. Question هلا select the VT graph that represents the motion during 12 seconds. Okay, نحن اتفقنا it starts off at, it goes up to 16, then we said it stays constant for 4 seconds, and then it goes down again until when it reaches 12 seconds. If they continued like this, then this would be correct, because we said it reaches negative قصدي شو قصدي لا يا الله, we said it goes up until v equals 16, right? It goes up to 16, then it plateaus, it stays constant because here acceleration is constant. Then when it reaches 12 seconds, we said v equals 0, so it goes down to back to v equals 0 at 12 seconds. Again, this question, guys, I doubt they will bring it. Yani, it's not part of our material for this week. A sports car moving at a constant speed of 20 passes by a stationary police car. After 10 seconds, the police car accelerates uniformly to a speed v in 10 seconds, and then continues the pursuit at the same speed. The police car catches up with the sports car in 60 seconds. The distance traveled by the sports car between the instant it passes the police car and the instant when its police car catches up with it is how many kilometers? So let's see. Here they want the distance, and we have velocity and we have time, but we have a lot of times. So we know that x equals vt. This is part of our material. And the v we know is 20 of the sports car. But how much time? So it passes by the police car. It took the police car 10 seconds to start accelerating. Okay, so it took him, we waited 10 seconds. Then he accelerates uniformly to the speed in 10 seconds, and then continues the pursuit at the same speed. It took him 60 seconds to follow the pursuit. Let me see. What most people will do is they're gonna add 10 and they're gonna add 60. Why this is wrong? I think it's because they meant here, it's wordplay again. What they meant here is this 10 seconds was part of this 60 seconds. So you just add 10 plus 60 and you do times 20 and you get 1400 meters. They wanted in kilometers, so 1.4. سؤال سخيف جدا. Okay, very, very stupid question. But if I'm wrong, please correct me in the comments. But that's the only any solution I can think of. The speed of the police car V during the pursuit, the speed of the police car V during the pursuit is how much? Oh, I think I just figured out part A, why you just add 1. Okay, you add this 10 seconds is the same. They mean, no, after 10 seconds, he reached the speed V and in 10 seconds. So I think what they meant is this 10 is the same as this 10. So you do 10 plus 60 over here. Okay, then times 20. I think I got that. Okay, and then, okay, Anna, I've literally been solving this question. Part B, I've been doing this for 10 minutes. I can't seem to figure it out. Even ChatGPT, I'm getting the same answer as ChatGPT. I'm getting 21 point something. If this does come, I think the only reasonable answer to choose from here is 25.4. But I think it may be wrong. I think it's 21, honestly. Kaman, it uses UARM formulas. If you want my opinion, it won't come. If you do have an explanation in the comments as to why this is 25.4, please put it in. But Anna, I'm going to show you what I did and why I got 21 point something. Okay, now we know that the total distance is 1.4. There's two segments of the police car. أول شيء, it's speeding up in 10 seconds. So it accelerated. Okay, how much was the acceleration in those 10 seconds? It's velocity divided by the time. We don't know how much velocity is. We know that velocity is v, but the time is 10 seconds, right? So we know that the acceleration is v over t. Okay, So for 10 seconds, and then it continues at the same speed for 60 seconds, right? So let's see. We need to find the distance traveled when it accelerated, and we need to find the distance traveled during those 60 seconds. We know that the total distance that it adds up to is 1,400 meters, right? So the distance traveled by an accelerating plus the distance traveled at, like when it stayed at the same speed, when it stayed at the constant speed, it equals 1,400. The distance traveled when accelerating. How do you find x when you have acceleration and time? It's half at squared. We know that a is v over 10. So half times v over 10 times time squared. 10 is 10 seconds. So 10 squared is 100. 100 cancels with this. It's 10. It cancels with this. Becomes 5. So my x is 5v. 5v plus d when you had constant velocity. We know that the velocity is v, and it was 60 seconds. How do you find the displacement or the distance when you have velocity and time? We know x is equals to vt, right? The velocity is v and the time is 60, so it's just 60v. So 5v plus 60v, and we know it's equal to 1,400. So 65v equals 1,400. And if you divide, you get 21.3. Okay, like 21.5. So even this should be rounded up to 21 point, should be 22. I don't know. If you have a different answer, please let me know in the comments. Question 16. Okay, the VT graph below describes the motion of a particle. Tangent to the graph at point t equals 5 seconds, shown by a dashed line. Its tangent passes through 1 second, 12 seconds. When is it instantaneously at rest? Okay, here we're talking about at a V graph. When is it instantaneously at rest? That means when V equals 0, right? When does V equal 0? Over here at 8 seconds and over here at 13 seconds. The instantaneous acceleration at t equals 5 seconds. Okay, at t equals 5 seconds. Instantaneous yani slope of tangent, right? Let's see, the tangent we have, what 2 points can we use? We can use this point because it's at the corner, 1 second, and it's at 7. So 1 second, 7 meters. And you can also use this point over here, which is 7 seconds, 3 meters. 7 seconds, 3 meters. Final minus initial, 3 minus 7 over 7 minus 1. You get minus 4 over 6 equals minus 2 over 3, which is minus 6.6. Minus 0. Minus 0.6 67 meters per second squared. I think I did something wrong. Let me see. If I use this point over here, this is 9. 9 minus 1, 8. So 8 ahead. 2 minus 7 minus 5. Now you'd get the same answer. Minus 5 divided by 8. Minus 5 divided by 8. Oh, did I do something wrong? 7, 3. Unless the point isn't exact. Let me see. 2 points I can use on this tangent. This one is over here at the corner. This is nice and easy. 1, 7. Let me see. Is this not? Okay, we can use this, I guess. Okay, this is 4, 5. 4 seconds, 5 meters, and you have 1 second, 7 meters. Final minus initial, 5 minus 7 over 1, was the 4 minus 1, minus 2 over 3. Yeah, I'm getting the same answer. Minus 0.6667. I don't know, you'll get something correct to the choices. This mechanics quiz مش عاجبني. خلاص هيك خلصنا. Okay. The course revision, أنا بنصحكم to solve all of them, not only the grids. Okay, if you want to guarantee with a 100. Okay. But I will just be solving the grids. Okay, the graph below shows the variation of displacement. What is the velocity at t equals 4 seconds? Okay, we want at a certain time, so we want the instantaneous velocity. And when we want instantaneous velocity, that means we want to find the slope of the tangent, right? The slope of the I just want to am I recording? Yeah, okay. You want the slope of the tangent. And this is a straight line. We know that the tangent to a straight line is the line itself. So we can just find the slope of the line itself. Let's take these 2 points over here. 0, 24 meters. This is an xt graph. Even if they put for you s, just look at the unit. They're saying meters. Sometimes they trick you and they put a different letter instead of x. So 0 seconds, 24 meters. 6 seconds, 8 meters. So final minus initial. Okay, 8 minus 24 over 6, which is negative 16 over 6, which is, let's see, now where are we? Question 8, negative 2.7. Yeah. Question 10. When a car moves from an asphalt road into a rough dirt patch, its speed decreases from 20 to 12 in 2 seconds. What is the average acceleration? أكيد acceleration will be final minus initial. So 12 minus 20 divided by the time, 2, which is minus 8 over 2, which is minus 4 meter per second square. Question 11. How many do they have? It's until 1.1, 2, 3. Here, just 3 more questions. Okay, again, Anna, if you take my advice, solve all of the questions, not only the grids, because he will get also other than the grids. The diagram below shows the variation of a train's velocity over time. What is the acceleration at t equals 30 seconds? Okay, we want the acceleration, instantaneous acceleration. So in other words, we want the slope of the tangent, right? Let's see. T equals 30 seconds over here. It's a straight line, so isn't it the same as just, the tangent to a straight line is the line itself. So we take 2 points on this line. Okay, so it's going to be this point over here at 60 seconds, 21 meter per second, and 0, 0. Okay, this one here. So final minus initial, 21 over 60. Okay, which is, let's see, 21 over 60 as 0.35. Okay, here explain how to calculate the instantaneous acceleration at t equals 10 seconds. T equals 10 seconds is over here. If you want instantaneous, you have to draw a line tangent to the curve at t equals 10 seconds, right? So draw a line tangent to the curve at t equals 10 seconds. Draw a right triangle for which the tangent line is a hypotenuse. Acceleration is the slope of the tangent line. Let me see. كيف أصلاً هيك? Okay. They mean. Oh, okay. Wait. Let me take this to open board. Okay. I think I get what they mean. If you do this. Okay. Yeah. Okay. Yeah, and then, okay. So what they mean is draw a tangent line and then draw another, draw a right triangle for which it's a hypotenuse. You can draw this. And this. Oh, or, okay. Hold up. You can draw this. Okay. This is right triangle. The tangent line is the hypotenuse. So the rise, okay, the slope of the tangent would be the rise divided by the run. Okay, so let's take this point here. It should be I don't know, 20. Well, how do they calculate? They don't want us to calculate. They just want to explain. So the first thing you do is you draw a line tangent at whatever instant you want. Okay, and we want to find the slope. So how would you find the slope? You would draw a right triangle for which that tangent is a hypotenuse. Okay, and then step 3, the acceleration would be the slope of the tangent, which is rise over run in the triangle. The slope of the tangent, isn't it rise divided by run? Isn't it opposite divided by adjacent? Right? That's what they mean. Okay, the last grid over here. Question 18. What is the total displacement in 20 seconds? Is this the last grid? Yeah. Is the last grid. The total displacement in 20 seconds, أكيد is a trapezoid, so you just find the area of the trapezoid. Base 1 is 20, base 2 is 10, divided by 2 times the height, which is 6. This is going to be 30 times 3, 90. It should be 90. Yeah, 90. So, these questions like for example at 1 p.m. a car spotted. Oh, okay. This one I can do it fast. If it's at 1 p.m. a car spotted traveling at a constant velocity towards a street sign, determine the equation of motion. Equation of motion when you have constant velocity is URM, and there's only one equation, and that's x equals vt plus x naught. Okay, so its velocity is 25, so x equals 25. Okay, t plus x naught, 2000 meter away. I don't know. Wait, let me see the answer for this. 25t minus 2000. Yeah, x node is the position of the car, the initial position of the car with respect to the origin. Here, they're taking the origin as the street sign that's 2000 meters away. So if you were to think of the car over here and the sign is over here, it's 2000 meters away from the sign. So its initial position is minus 2000. Okay, this could come, easily you could bring it multiple choice. These at t equals 5 seconds is blah blah blah. Okay, you can do these. Well, let's do question 14 and 15 really quickly. Why is the VT graph in UARM linear? The acceleration represents the slope of the tangent. Since in UARM the acceleration is constant, then VT graph is linear. That makes sense. If the VT graph was curved, would it be UARM? No, it won't, right? We want UARM, that means constant. That means acceleration is constant, so that means it should be a straight line. Okay. How about 15? What did they say? Does a positive acceleration always mean that the body is accelerating? Explain. A positive acceleration means the body is accelerating only if it's moving in the positive sense, right? If it was a positive acceleration but moving in the negative sense, okay, it would be that the velocity is negative. And a positive acceleration in the negative sense means that its velocity is increasing and consequently its magnitude is decreasing, so the body is slowing down, blah, 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 blah. Okay, if it was moving in the negative sense. This question as well, question 9, I think you should do it. It's a nice question. Other than that, I can't really see. Maybe 7 and 9. Take you 2 minutes, just open the solution. They're not hard questions, والله. Like that, خلصنا recording. Thank you so much for watching and good luck.